Cabal HQ to Beastie, come in. You are go for Operation SCM. Over. Roger that. Over. Beastie to HQ, holding at landing zone. Over. HQ to Beastie, you are go to deliver the package. Over. Roger that. Over. Beastie to HQ, package has been delivered. The cat is amongst the pigeons. Over.
Hey, what's this package that just got delivered to the core team? Let's open it up and check it out. Well, that was amusing. The FreeBSD project doesn't make its decisions that way. When we decided to switch to Git, we had a number of reasons. There are no black helicopters. There is no FreeBSD cabal. Hi, my name is Warner Wash, and I'd like to tell you some of the reasons we switched to Git. Subversion use is waning. The project knows from a number of different data sources that subversion use is waning, both in the industry and in open source projects. If you look at the number of open source repositories that are used, according to OpenHub, you see a very clear trend. If you look at the number of searches for Subversion versus Git, you see a similar trend, perhaps more pronounced. Next, we know that the Apache Foundation has strongly encouraged all of its members to move to Git, and they have recently entered into a number of agreements with GitHub to provide Git services. Since the Apache Foundation is the main caretaker for Subversion, this leaves Subversion's future in doubt. The number of open source projects that are using Subversion is declining. The number of large ones significantly so. As far as I know, only LLVM and FreeBSD were using Subversion until recently. LLVM made the switch last year, and FreeBSD is making the switch this year. The FreeBSD project focuses on writing a world-class operating system. We do not have time to write source code management system, so any threat to the future of Subversion is a problem. Next reason, Git has stronger integrity guarantees. While we were converting to Git, we discovered a number of errors in the mirrors of the FreeBSD Subversion project. This sounds very scary, so we investigated thoroughly. We discovered that these errors were only in the metadata, the data about when the commit happened and who made the commit. There were two causes of this problem. One, some versions of Subversion do not reproduce with fidelity CVS's forced commit notion. This caused some errors in some of the repositories. Next, the mirroring process is two phases. The first phase grabs the commit, commits it as svn mir. Second phase then adjusts the user and other metadata using administrative commands. If the mirroring process crashes in the middle, there's nothing that ensures that this will be cleaned up later, so the error persists. Therefore, different repositories had different versions of the metadata. Git's mirroring is built in from the start, so it's robust and reliable. In addition, Git provides a way to sign tags and revisions to increase the integrity of the process for examination by third parties. This will allow, for example, the release engineer to sign releases directly in the repository. Next reason, Git's ecosystem. When the FreeBSD project adopted Subversion in 2008, Subversion had a commanding market share of source code repositories. Depending on whose data you look at, this was somewhere between 55 and 75% of the market. At the time, Git had only a 2, 3, 4% market share. Fast forward to 2020, and the tables have largely turned. Git now commands a 70 or 80% market share, depending on whose data you look at, and Subversion maintains a more modest 15 or 20% market share. The explosive growth in Git from the last 5 or 10 years has spawned a robust ecosystem built around Git and collaboration. There are a number of websites whose entire business model is this: GitHub, GitLab, SourceForge, all of which provide Git mirroring with additional added services to help with workflow issues. In addition to these websites, there are a number of companies that make add-ins specifically for Git and continuous integration. Continuous integration is one of the areas the project would like to invest time and developer resources in towards improving the quality of the project. Most of the tools out there support Git and maybe Subversion, maybe not, and if it does support Subversion, usually it's not so well. So this limits our ability to adopt the best continuous integration strategy for the project to increase the project's code quality. An additional benefit of the rich ecosystem is there's a lot of information about how to run a Git repository, how to handle mistakes. There are a number of Git tutorials, so the FreeBSD project doesn't need to produce all of these for its users and developers. The project then needs to only document how it's using Git rather than provide a complete Git tutorial. This series of videos, for example, are trying to do that, but will not provide a complete tutorial of all aspects. One side effect of this large ecosystem is that universities are now teaching Git. This means most developers trained today already know how to use Git and don't need to learn it. If they were to use Subversion, they need to learn it. We have heard anecdotal evidence that having to learn Subversion is a barrier to entry to the project. In addition to the widespread support for continuous integration in Git, Git's distributed model actually helps us create better patches, both as individual developers and as small teams that are collaborating to produce better patches. Git allows one to rewrite history. This may sound scary and bad, and for a lot of people that have suffered through CVS repo surgery, there's a cringe reaction to it. However, it's actually a positive. Developers can curate patches so that they can deliver a set of independent, logical patches to the project for integration into our tree, rather than the more haphazard actual history of development of patches tends to be rather chaotic. These curated patches will allow for better bisection of different revisions in the repository, as we will have fewer oops commits to the repository as well. Doing this sort of patch curation is basically impossible with Subversion because it's a centralized repository. All of these benefits don't come without some costs. Here are the costs that we're aware of in migrating to Git. First off, until recently, there were no BSD licensed Git clients written in C. However, last year at EuroBSDCon, Stefan Sterling presented a talk on Game of Trees. GOT is a reimplementation of CVS using a Git backend. It's designed for a number of simple workflows. And these workflows match well what users of the project who have tracked changes traditionally have done. We'll be able to put GOT into the base system. However, not when we do the switch. Just like when we switched to Subversion in 2008, GOT won't be ready to go right when we do the conversion. We will integrate it before the next major release, however. Next up, Git doesn't track copies and merges explicitly. Git infers when files have been moved around or copied. It uses a rather sophisticated algorithm to do this. Subversion tracks it directly. Now, for large source spaces, such as the FreeBSD source tree, this doesn't present a problem because the files are mostly unique and it's really easy to see when a file is moved, maybe with a few changes. But for the FreeBSD ports tree, where most of the files are mostly the same with small tweaks for each individual port, it becomes much harder. We anticipate that the ports team will need to come up with some additional process to overcome this limitation. In addition, merges aren't tracked directly. They're inferred as well. In fact, there are two types of merges. In Subversion, when you join two branches together is a merge. Also, when you copy individual revisions from one branch to another, that's also a merge. Same commands are used, same merge history is kept, everything. In Git, these are two different things. In Git, a merge is only the joining together of two branches. When you copy a revision from one branch to another, that's called a cherry pick. Git does not track cherry picks. It infers them. There are some commands you can use in Git to try to figure out which revisions haven't been merged yet into a particular branch. They're not as precise and accurate as the same commands in Subversion. However, their functionality is likely sufficient. Next up, Subversion has a strong sequential numbering of commits. Git does not. Git uses hashes. This is a direct result of the distributed nature of Git. It can't possibly know all of the commits that are ever going to happen to the repository. The nice thing about Subversion's numbering of commits is that we can tell people, hey, if you have version 234, you have the fix. And they can go out and look and see they have version 222 and know they don't have the fix, or they have version 255 and know they do. That's much harder with Git. To work around this deficiency, Git produces a version of the tree that is based on the most recent tag and the number of commits that have happened. This string is already incorporated into kernels that are built from Git, and we will need to probably augment the build system to include one of these in the installed tree. Finally, the big one, keywords. In Subversion and CVS, the project has grown used to having a keyword in every file. This keyword has metadata about the file that is filled in by Subversion when the file is checked out. This lets users track the files that they've gotten from FreeBSD so that when they make changes to it, they can come up with diffs to port the changes forward or do other things with it. Git can't support that. Git does have a limited amount of support for ID tags, but the revision information that's put in there is not very useful. It's the hash of the blob inside of the Git repository, not the hash of the most recent commit for that file. However, people have written tracking scripts that take a Git repository and the files in question and come up with a most likely revision. While less than ideal, this will likely suffice for most of our users. So there you have it. The pros and the cons of the FreeBSD project switching to Git. We believe that the concerns about Subversion's future, Git's rich ecosystem, and Git's improved support for continuous integration are all compelling reasons for us to make the switch. And they outweigh the disadvantages. So there you have it. This is the second video in my Git migration series. If you'd like to watch future videos, subscribe to my channel, like this video. In the future, we'll cover more tutorial things, like what are the changes that a user can expect to see, a developer, and so forth. We'll step through them so that users not only know about what is going to happen, they'll know exactly what they need to do once the cutover happens. Thanks for watching.